Good afternoon, everyone. Uh, Welcome to this session. So today I'm going to cover basically what I call the T-SQL for cloud native developers, that part of it, and basically what is there in T-SQL to make it easier for you to develop such code in SQL, right? I think in the earlier session you would have seen Davide and Brian kind of show the REST API integration, right? And how that can be used to consume JSON, XML, and so on, right? So here we'll focus more on what are the server capabilities which are available, right? So that's what we'll go with. Okay, yeah, so this is the survey slide. Myself, yeah, I've been in Microsoft since 2004, and yeah, I worked on a lot of features, and right now I'm looking at JSON and basically string operations, like how to make them better in T-SQL, right? So this is the agenda I have. First, we'll start with a quick intro of JSON. I mean, I don't know, I think most of you would have used it. We'll look at what kind of standards are applicable for JSON and how that's relevant for SQL Server, right? Because that's important in terms of functionality, like what you can do with JSON, right? Then we'll look at what are the facilities available in SQL Server today and Azure SQL today, right? And then lastly, I'll do a demo of the JSON types, which we announced for private preview earlier during build, right? So that's something to look at. Okay, so what is JSON? I mean, it's basically a data exchange format, right? It's a very lightweight data exchange format. It has like only very few types. It's primarily used to move data between services or applications, right? And if you look at the type system here, there's only like number strings, right? And then for Boolean, there is special values, a null, and that's it, right? Everything else is either objects or arrays. So now that means when you actually send data from, say, SQL, and you want to transform to JSON, you need to kind of keep this in mind. Like, for example, you have a date column in SQL Server, and you're converting it to JSON. I mean, it will end up as a string, right? And that means that property could be either a date value or it could be even some other string, right? So in that sense, I mean, it doesn't have the same fidelity as SQL, but those are like, I mean, like pros and cons. Then the other thing to remember is it's all of the string format in JSON is pretty much UTF-8, right? It's primarily used for services and web APIs to talk to each other, right? So that means when you are dealing with string data in SQL, you need to kind of keep that in mind, right? If you're not using a UTF-8 collation today. Actually, how many of you know SQL has a UTF-8 collation? Okay, so traditionally you would do nvarchar, right? Which is basically a Unicode data type, and it uses UTF-16 encoding, right? Which is different. And UTF-8 is predominantly used in Linux, web protocols, and so on. Right? So when you deal with JSON, everything will be UTF-8, and the comparisons will also be case sensitive, right? So that's something to remember. We'll look at it as we get through. So JSON has many standards. I mean, it kind of evolved from JavaScript, right? And there are standards where the JSON format has been used for geographical data, right? So this is something at some point we want to integrate into T-SQL, right? If you look at spatial today, there are ways to create a geography data type or a geometry data type in T-SQL, right? And usually you would give it like a text value. Instead, you could use like a JSON format at string. So that's one of the standards. Then there are standards for like how to merge two JSON documents, right? So if you have a document in the database and you have some new data coming in, how do you merge them, right? So there's a standard for that. So some of these we have the capabilities today to do it, and other places we don't actually have it now, right? So that's something we're looking at. And lastly, since it's a SQL language, the AMC standard also has an extension for JSON, and they define what functions and what operators are available, right? And that's something we implement today. Okay, so this is a slide I kind of put together based on some information which we already published, like what does a cloud native developer do, right? So they are primarily creating microservices or interacting with microservices, and those are all typically REST API calls, and JSON is the way you send the data, right? And this kind of shows like a typical architecture where you have a mobile app sending data. I mean, it can go to the database. It can, there is, I think, a relational database shown here. The database can emit some data over to like a Azure Event Hub, for example, and you can do something with it, right? So this is like basically JSON is used all over this place. So that means if you have a database application, now you want to actually be able to manage JSON documents and data in an easy manner, right? And that's why we kind of added these capabilities in T-SQL. So JSON was added back in 2016 release of SQL Server, right? And it's available now in pretty much all the places where we have a SQL product, right? And today you will store the JSON document as just a string column, right? It can be stored in varchar or nvarchar, doesn't matter. Right? And the way you would interact with JSON is all through like some set of functions and operators, right? So which is what we'll look at. So what are those functions? One of the first thing you would want to do is, okay, I'm getting a string. How do I know if it's a valid JSON, right? So you want to validate it. I mean, that's basically, there are functions which can do that for you. This is similar to like isNumeric or isDate functions, which we already have today, right? So here you can test a character string and say, okay, does it contain a valid JSON? If not, you can throw an error, right? The other one is querying. So, I mean, once you put the data in the database, I mean, you want to be able to query it efficiently, right? And so here there are some functions available. This is again from the standard. So we implement the same functions. And these are functions which you would use to get individual properties out of a JSON document, right? We'll look at these examples in a bit. And then there is a function to modify the JSON document, right? So like the name implies. And lastly, you may have a lot of data in the relational format, right? Like your existing tables. I mean, what if you have an application which wants to get the data in the form of a JSON document, right? So basically, you don't want to change your schema. So in that case, you can use some relational operators and functions to transform your existing table into JSON, right? So this way, you don't have to, you keep your existing schema as is, and you can still integrate these new services into your application. And the last one, the constructors and the JSON path exist. This we added in SQL Server 2022. Right? And it's available now in SQL DB and SQL MI. So now we'll look into details of what this JSON does and how you can use it, right? So it's a straightforward function. You give it a string and it'll give you a bit value, which can be a 1 or a 0, right? It can be null if the input itself is null, right? So here are some ways you would use it, right? So you can say, is JSON 1, or you can similarly use a JSON value function to extract a property out and check for the value, right? So these are ways you would use it. So here is an example of these JSON, right? So typically in a relational table, you would put like a schema constraint, right, on certain columns and properties. And same thing you can do with the JSON, right? So you have a JSON document which is being stored in the table. Now, how can you put constraints saying, okay, this property should exist, this value should be filled and so on, right? So this is where these JSON function can be used, right? And here are some examples of how it can be used. So the first example is basically a check constraint. You just call this JSON, and if it returns 1, it's a valid JSON, right? So that's the simplest check. So there are some gaps with the current is JSON in the sense it cannot distinguish if the string is an array or an object, right? If you give it either, both case it will say true, right? But there are scenarios where you may want to actually look for a specific format, right? Like imagine you have a, order processing system, you're getting a bunch of products as an array, and you want to make sure that the input is always a valid array, right? But instead, if say the app has a bug and they send a JSON object instead, and which you don't want to store, so those kind of validations are harder to do, right? This is one of the gaps which are we basically addressed with the new enhancement, right? So the new enhancement allows isJSON to basically take additional parameter, right? So now you can say, in a given JSON document, okay, is this a value? Is this an array or an object, and so on, right? I'll explain each one what it means. The array it just tells you, okay, is it a valid JSON array, right? Is the string a valid JSON array? So if it's not formatted correctly or if something is missing in terms of syntax, it will give a 0, right? The object specifically checks for whether the string has a proper object. Again, these are capabilities which you would use in a regular C# or a Python code also, right? Say you are formatting a string and they usually have like a JSON writer, and you would use that to construct valid JSON, right? So here in T-SQL, if you were to use strings or something to concatenate and generate a JSON document, you can use these functions to validate it. The third one is the scalar. Like I said, JSON, the type system is very kind of primitive, right? So it only distinguishes like two things, like number and string, pretty much, right? That's it. Everything else is all objects, right? So this scalar will check if the particular value is really a number or a string. And then the last one is general function, it's the same as isJSON pretty much. Okay, so that was isJSON. So now in 2022, we added the JSON Path exists. So like this one, like the name implies, it basically tells you if a particular path is existing in the document or not, right? So it's you would typically use it to verify certain individual things in the document. And this is also implemented like isJSON, it returns a 1 or 0, right? Bit value. Again, this one of the reasons why we added this was to, again, address some gaps which are there with the current functionality, right? Where in some cases you can't really distinguish in a particular path what kind of object or what kind of value is there, right? And you don't really care about it, but you just want to make sure that the path is there in the JSON document, right? And that's one of the use case for this. And today, I'll show a demo of this in a bit, and you'll have to do a lot of workarounds to implement that. So that was the other one. And same with this one is again another example where you are checking for a specific property, like this is a info.tags, and it could either be a string or it could be an object or an array, right? So now you'll have to write all of this complex logic to make sure that you're not missing anything, right? And this can be simplified by the new function because it simply tests if the path is there, right? It doesn't care what value is there. With that, let's go and look at how this works. So here is a select statement, right? And in this I have many strings, right? And in the newer JSON standard, a root document, which is basically a value like this, is also considered a JSON document, right? So these are an examples of JSON, valid JSON document. And similarly, I have here number. You could have a floating point number, like using the scientific notation or a decimal notation. And in the case of JSON, all of these are considered numbers, right? So like in T-SQL, for example, an integer is you cannot store like a decimal value there, right? Whereas in JSON, a number can represent any of these, right? And then this particular string represents an array, a JSON array, right? And it usually starts with a square bracket, ends with a square bracket, and it can contain any of the other objects or values and so on, right? So now if I run this, what I've done is I've used the new isJSON parameters to actually test what each one of this could be, right? So in this case, like if you see here, I'm checking if it's a valid JSON value or not, the document. And here it will say true, right? It's fine. Whereas currently, with this JSON, without the optional parameter, it basically will tell you if it's, I mean, it won't test for values like that. Right? So these are some examples of how you kind of can use this function, right? And if the input itself is null, I mean, everything will be null, just like most functions in SQL today. Right? And here is an example of how the numbers are treated, right? So those are treated as both values or scalars, right? And that's why in this case, you can see that, okay, all these number formats, they're all considered valid JSON, right? And again, if you make an error here and say you put this way, right, it's going to say 0, right? Because it's not a valid format. Similarly here, it's a valid array, so it's going to say it's a valid JSON value and it is an array, right? And this is an example of a JSON object, and this is where the ambiguity comes for isJSON without any parameter, right? See, it will tell both are valid JSONs, I mean, which is true. But if you want any constraints like, hey, I want to have only an array or I want to store only an object, then you need to use these new optional parameters, right? So that's basically the use case for this one. So any questions on this? Good. So it's very straightforward. It's basically take some string, validate it, and we validate it according to the standard. And I mean, that's the same capability on the client side. Okay, so next what I will do is I'll show a demo of how the JSON path exists can be used, right? So here I have a table which has an integer column and a string column, right? Doc. And I'm going to store a JSON document in those columns, right? One of the constraints I want to impose is basically some path. First I want to check, okay, if the document is a valid JSON or not, right? So I would use this. And then on top of that, I want to say, okay, is there a path which exists like this, right? So if you have not used the JSON path notation, what it means is it basically starts with the root of the document. That's what the dollar represents, right? And then you use a dot notation. So for example, if I want to get to info, I'll say $.info, right? If I want to get to address, I will say $.info.address. So that's how it is. So it's a hierarchy, and everything, the keys are separated by a dot. So here I am saying, okay, I want to check if a type is there in the document, this key. So now let's see what happens if I run this. Right? I get a check constraint conflict, even though I mean, as I would have expected it to run, because in this case I have a type, right? And this value is set to null, right? But today JSON value cannot really distinguish any of that, right? Because it simply returns whatever value is there in that location. And it also returns null if it happens to encounter an object in that place, right? So now what you would do is you would again do one of these things, like you basically write it like this and check for is null, right? I mean, if you are familiar with coalesce or is null, it basically checks if this value returns null. If so, it will return an empty string instead, right? So this is kind of one workaround. The other ways you may want to write like a function like this and use it. So instead, what you can do now is you simply test for the path, right? So the big difference between the other one and this is here it doesn't care what exists in that path, right? For my application, I'm saying, okay, I just need some valid document, and I want to make sure that this particular property exists in the JSON document, right? And that's what happens here. And here are some examples of how you would actually use it, right? So let's run this. So let's see. So like I said, it's a dot notation. So here, this is what all the difference between these functions. Again, it's a simple example. I'll show like an end-to-end of how to use this, right? So in this case, I have this info.tags, right? And I can check for the path like this, right? And here is how a difference of the value and the query functions look like. Right? So if I say, in this case, let's look at this document. This has got a JSON array, which is this property value, right? And here, if you see, it's actually just a string, right? So this is one thing to remember with JSON is it's a very loose format, unlike SQL schema. I mean, a single property you can put anything in there, right? I mean, it doesn't matter, right? And it may not even exist. So in this case, what happens is if I run this function, I mean this query, you will see that the value for this particular first row is empty, right? The JSON value call. Like, let me scroll a little bit here. This one. Right? Because it only returns a scalar value. If it finds something else in that place, it doesn't look at it, it will return null, right? The JSON query does the flips. So if it returns a value, it can only be like an object or an array, right? So that's why you see these differences. So this is something to remember is basically this function, the JSON value, can be used only to get scalar values out of the JSON document. And this one, JSON query will return only objects. So that's why you see the difference here. So that means if you are writing some functions to or some logic to deal with this, you need to know the difference. And this is one of the advantage of JSON, and at the same time, like a, I guess, disadvantage, right? Okay, so now we will look at some operators which are functions which are used to construct JSON from a relational data, right? Like I said, you can start with your existing table or schema and then go and incorporate JSON into it, right? So today we have this for JSON operator. Are you familiar with XML, for example, like in SQL Server? Yeah. So it's there. Similarly, there's like a for XML. So same thing here for JSON, right? So you can have a query and say, okay, give me the output as JSON using for JSON, and it will return a JSON string, right? And this operator behaves like an aggregate. It basically takes the entire result set and transforms it. You don't have any control over what shape it is and so on, right? So there are some issues with this one. So the ANSI standard, however, defines some set of functions which are very specific for that use case, right? So these are the things which we implemented new in SQL Server 2022, right? So the first function, we'll go with that. That's a JSON object. Like the name implies, it basically takes some set of values and converts it into a string, which is a valid JSON object. Right? The JSON array does the same thing, but it will produce a JSON array, right? And that means you will have the square brackets, it will validate it, it will format it with the comma and so on. And in addition, there are some constraints in terms of, okay, what do you want to do with null values if they are there, right? I mean, SQL language has the 3-valued logic. JSON also has a null value, right? So you may want to say, okay, if I see a null, maybe I don't want to include it in my array, right? Do I want to drop the value or not, right? So those are some options which are available. So this is how the JSON object syntax looks like, right? Yeah. Question is, if you have a JSON string, how do you turn it into an object? I mean, JSON string by definition is some JSON object, right? This function, what it will do is, if you were to take the JSON string and put it in a particular key, it will include it as that object itself, right? Because in JSON, a property can be, I mean, it's all a nested document format, right? The property can be a value or it could be another JSON document itself. Otherwise, if it's a normal string, it will format it. I'll show you an example of it. So this function basically takes some bunch of key value pairs, right? And you can say, okay, if I find a null, what do you want to do with the null? Do you want to still put a null value in that property or just remove the whole property, right? So it's a simple control. So this is how you would use it, right? So you can pass it, use it without any parameters, in which case it's going to give an empty JSON object, right? Or you can give some optional parameters like this, right? You specify a key name and a value. And it can be many of them, right? Like you can put as many as you want. You can also use variables in there as parameters, right? You can have query itself, a subquery itself in there, user-defined function, doesn't matter. Whatever you can do with a SQL function or today, you can do that here, right? So it behaves like a regular function. So the JSON array looks exactly the same, right? Except it takes some bunch of array values. And same thing here, like you have a class to say what you want to do with the null value, right? And the usage of JSON array looks exactly like JSON object, except you don't have the key value pair, right? Because it's an array. And here you can pass whatever input you want. If you are passing some SQL types which are not available in JSON, those will be converted to strings, right? So in this example, current timestamp will return a date time value, right? And the date time type. Whereas JSON doesn't have a date time type, like I said, right? There's no timestamp or JSON timestamp type. So what it will do is it will convert to a string and put it there, right? Same way, if you were to take like, I don't know, hierarchy ID value or something and try to put in JSON, I mean, you have to transform it to strings. Yeah, so same example here, like you can pass variables and just a query, for example, anything, right? So let's quickly take a look at that. So what I'm going to do is first create a table, right? Like which looks like this, right? I have few rows in there, right? So typically a relational result set will look like this, right? I mean, in SSMS, every column separate and you see the values. So you can include the for JSON operator and say, okay, at the end of the select statement, you put this for JSON auto, right? So now what happens is you get one big string instead, right? And it's basically a JSON document. So how the transformation works is it basically takes every column, right, and puts it as the key name and the value of the column in that key, right? And then every row becomes a JSON object. So in my table, I had 5 columns, right? Like, let's go back. Yeah, I had ID C1, C2, C3, C4, right? So that means every object will have these 4 properties. In some cases, you can see it's not even there, and that's because the column value was null, right? So it puts all of those as column names as the key name, and then the value is the value itself, right? And here we will do conversion. So like in the 4th, this row, right, you saw it was empty, right? If I run this without the JSON, you'll see, right? Some of these are null values, and those properties will be completely omitted. So now here are some examples of other ways to transform it, right? So you could generate only one column as a JSON document, right? And this is how you would kind of do it. Similarly, this one shows how you can generate a JSON document without the array wrappers in there, right? So it's just an object. Like if I copy this, it'll look like this. Again, these are more examples of how you would leverage like some SQL functions to concatenate and produce a JSON document, right? In this example, I have I'm using JSON Path to generate an array, right? That is the values. I can't even see them. It looks like this, JSON object with the array, right? But the array is not formatted properly here, right? Because I have to go put square brackets around it. So it becomes ugly with the string functions. So now let's look at how the same thing looks with the new functions, right? So here I can say something like JSON object. I put the name of the column. I give the value which should be put in that property. And then the property itself can be generated as some other nested JSON call, right? So in this case, I took the column values and I'm constructing a JSON array, and that ends up as a property in the JSON document. So that's this example here. Right? It shows like this. Now same thing here, like if I have a null, what do I want to do? I want to either put the null itself or drop it. That's something you could control, right? See here, you can see that it also put the null value in the array. Or you could say absent or null, in which case it's not going to include it, right? Here are some more examples of this. You can give any ad hoc values to it, different types, right? It's going to convert everything into a JSON string, right? it will format it and return the value. Same way here, I'm going to use some types like date time, right? So here you can see, let me paste it here. In this case, we will convert everything to a string value and put it as a string, right, with the double quotes. Whereas if the type exists in JSON, then it doesn't matter. We'll put it in the same format, right? Now, here are some more examples of how you could probably use it. Like say I have some table, I want to take some properties and create a JSON document, right? So in this case, I took the catalog view, name of the objects, and some properties, and I can generate a single JSON object and return this kind of result set to the application, right? Same here, I can say instead I want to return it as some JSON object, but with the for JSON operator. So these two are identical, except this is slightly more, I guess, easier to use because it looks like a function call and it's kind of natural to use. Okay, so let's head, oops, where is it? Back here. What was the last one I had? Yeah. So JSON operators, so these are the three operators which are there. I mean, the last one is not really specific to JSON, but it can be used to read JSON documents. The for JSON, I kind of showed you that it takes a relational data set and transform to JSON. Open JSON is another one which basically takes a JSON document and produces a relational result set out of it, right? It's a reverse scenario, right? In some cases, maybe you take the JSON and you want to store it in relational format. In other cases, you have a relational data and you produce a JSON document, right? So if you have both the functions. And the last one is just open roasted bulk to read a file which contains JSON and then you can do something with it, right? So these are standard capabilities. So now let's look at how some of these look. So first I'm going to show how you can store a JSON in strings, right? So here I have this orders table and I have an integer column and a string column, right? It's nvarchar 1000, right? And I can store a valid JSON document as a string in that column. And to make sure that it can be only a JSON formatted string, I need to use this function, right? So I'll use this function. So that's what this check constraint does. So I can now store this document in this table, right? So it's a regular SQL table, but one of the column is a JSON document. But to the engine, everything is just a string at this point, right? So you can see here it's just a string. So now what are the use cases, right? So now I have in this JSON document some properties, like for example, account number, price, quantity, address, and so on, right? So I can use these functions now to extract these values. Say why you want to build a report for the JSON document and you want to get only some property out of the document, right? And that's one of the use case here. So you would say like something like JSON value and give the path. In this case, I say dollar dot and account number, right? And it returns a account number, right? And this would be just a string, right? Similarly, I can query the entire object itself and return it as a string. And this example here, it shows how to use the SQL aggregates creator, right? So now in this case, I have two documents which has some price and quantity values, right? So what if I want to do some aggregates on that, right? Because that would be one of the good things once you have it in the engine is like you can use the SQL capabilities, right? So I can extract the values like using the JSON path and then convert it to some SQL type, right? Remember, in the JSON document, everything is string, right, for us. Like, it's not, we don't have a type there. So then, yeah, we can say, okay, now I want to convert this price value to a float or integer as appropriate, and then I can do simple SQL queries on it, right? So these are all transformations you could do. Now, same scenario, like you imagine I have this JSON document and your application modifies the quantity or modifies the zip code, right? So instead of constructing the whole document and sending it back, you could actually send the individual values, right? And then use JSON modify function, like the name implies, to change the document, right? So this looks like every other JSON value, JSON query function. It takes a document, it takes a path, and it takes a value which needs to be put in that path. So it's very straightforward. So 3 parameters, right? So in this case, like once it's modified, you can see quantity would become like 4. In this case, zip code, I changed the zip code from 90874 to 52. You can kind of see it here, right? So that's what it does. JSON modify just modifies the data. Now the next scenario I'm going to show is I have a relational table, but I'm getting the input as JSON, right? And now I want to take or shred the JSON document and put it in individual columns. So that is the scenario, right? So I have one accounts table which looks like a regular SQL table, right? Like with all of these properties, account number, phones. And I have another orders table which have the individual columns. But I'm getting, say, input from my application as a JSON document, right? So here, first let me run through this. So what I can do is, I already run this. Okay, so here I have in the string for the purpose of the demo, I have a valid JSON document here with 2 objects, right? So you can see it's an array and there is one object, right? And then there is another object. And I want to take each of these properties and put them into these columns, right? And each one becomes a row, each of these objects. So this operator is the open JSON operator, which basically takes a JSON document and then you can say, okay, how I want to extract the properties, right? And what type to transform it to, right? Because like I said, SQL has a different type system. JSON has just number and strings, right? So everything is going to be either a number or a string. So I can say, okay, I want to transform the string in this date path to a date time 2 value, right? So that's what I specify here. Same way, some of these could end up as decimal, integer, float, whatever, right? And you can see here, I mean, this is an insert statement where I inserted it, and I'm also showing the results here. So it shows that everything has been inserted as individual columns and values in the table, right? Now the same application, maybe like it wants the data as JSON, right? So that's the same scenario. I now have all the data in a relational format, compact format, and I can still produce the JSON documents to the application and return it, right? And that's what is shown here. So here basically I have JSON here, and I've constructed all of these from the same relational table, right? So I can say, okay, how I want to format the JSON document. Do I put an object there or an array, and so on. So in this case, I've taken all of the columns and put it into a specific format, JSON, right? And again, this could be nested. You can transform the entire result set as one JSON if you want, or only individual rows, right? In this case, I transformed each row into some JSON document. Okay, so that was that. Okay, and the last one I want to kind of talk about is the what we announced for private preview back in build. And some of the demo I showed was you are storing the JSON document as a string, right? So that means everything is strings to the engine. Again, wherever you want to deal with JSON, you have to treat it as a string, right? So this is where many databases like Postgres, Oracle, they all have a JSON type. Just like SQL Server has like a XML type, they also have a JSON type, XML type. So this was one of the gaps which we want to address. And so we now have a preview of the native JSON type, right, which I've shown a bit. So now in this case, you would still give the input as a string, but the engine will store it in a binary format, right? So it's much more optimized, compressed, and we can do more efficient things with it. Then we also have a few aggregate versions of the JSON constructors, right? Just like today you have string ag, which can take, say, some column values and produce a comma separated string, right? So similar to that, instead you want to aggregate and produce a JSON document instead. Right, so these are some capabilities which we've announced for private preview. If you're interested in the preview, you can sign up here in this URL, right? That has the details. Okay, so now let's see how the same similar example looks with the JSON type. So let's go back here. So now the big difference between the previous example here, where I have, let's show here. Where is it? Yeah. So here I have the same orders table, but my column is nvarchar, right? So now instead you just say it's a JSON type, right? So the name of the type will be JSON. You don't need a check constraint because since it's a JSON type, only a JSON string or a JSON document can be stored. Just like today, if you have an XML column, you cannot store an integer value or like I don't know, date time value in there, right? Same thing here. So you say it's a JSON, you don't need the check constraints like this because it's going to allow only a JSON object to be stored, right? And that's it. So otherwise, in terms of how you actually use the type or see it, it's just like a regular string. You insert some values into the JSON column, right, as a string, and you get back the result also as a string, right? I mean, here you can't really see the difference yet because initially all the clients will just simply see it as a string. Now, once you have the JSON type, again, same capabilities. I mean, you use the existing functions which you are using today, right? Like the JSON value or JSON query. And you can reason over the JSON document, right? Now, the main difference between the previous approach and this is with the string, every time you call a JSON value, we have to go parse the string, right? Because to the engine, that JSON document as a string is no different than any other string in the engine, right? So we don't know if it's a JSON or not. Whereas here it's already JSON, it's already in a binary format, so we can do all of these paths searches more efficiently. But otherwise, functionally, you wouldn't really see the difference. The way you would notice it is like just in terms of performance between the previous approach and this approach. And this example just shows how the metadata will look, some types. Again, this is not mostly relevant as an application, but something like SMO or DACFX would leverage this, right? Same if you are writing a .NET app or Java app, they will see this JSON column as a varchar max column, right? So that way, if you just simply read it as a string, and then you would use any JSON parser in the client side. Right? Once it's a built-in native type, you can declare variables of the type, right? And use it wherever you can use a regular SQL type, right? As a parameter to a stored procedure, function parameter, whatever. Right? And here I'm just showing an example of storing a JSON string in this type, new type, and you basically query it, right? And again, these are all existing functions which will also work now with the new type, except they would be more efficient. Any questions on the type? The integration would be mostly similar, I mean, because you just simply change the string column to a type and use it, right? So, I mean, in terms of usage, you won't really see a difference. But the format would be more optimized. That's where the benefit would be. Okay, so now I'm going to show you how the aggregates work, right? So let's first create these two tables, accounts table and orders table. I mean, the data is shown here like this. Now, usually what happens, like if I use the JSON object or JSON array, it's one row at a time, right? Because these are just scalar functions. It's like substring or length or like date add, like that, right? They can only take one value or some set of values and return a single value, right? So now what if you want to take all of these rows, right? So in this example, I'm having, I have two rows in this table, right? Or in this query. So now what if I want to construct all of these two rows and put them in one single JSON document, right? So that's where the aggregates come into play, right? Just like today, if I were to take this and use string ag, I could format like a string out of these rows, right? Same thing. So now instead I can use a JSON object ag. What it will do is it will take the input, which can be JSON itself, and produce a single value out of it, just like any other aggregate in T-SQL, right? So now you end up with one big JSON document. This is similar to sum or like, I don't know, count, whatever, right? It takes my n values and produces a single value out of it. So same thing here. So I pass all the rows and you can construct each row what value it means, right? It could be a JSON object, it could be a string, anything. And then the aggregate will take all of these individual rows and put them into a single document. Now same thing with an array. So instead of a JSON object, I want to transform and put an array instead. So these are just, you can think of it as primitives which are used to basically create different shapes of documents. Same example here is just a cooked up example where you can use with group by, right? Once it's an aggregate, then you can use it wherever an aggregate can be used. That means with group by class, you can, in this example, all I want to do is group by a column, schema in this case, and produce two JSON documents, right? Which are actually aggregated from the individual values. And you can also use existing aggregate functions. It doesn't really matter, right? And In this case, the only difference is it's the value itself is a JSON document. So as you can see in this one, I put the name and the object ID here. Right? So that's what you see here. Similarly, if I click here, this is just going to be list array of object IDs. Right? So again, these are just like very primitive aggregates. You can basically use just like any other aggregate, except it produces JSON documents. Right? Any questions on this? So this was all the, this is a private preview functionality. Yeah. No, anything. I mean, you can put, I mean, in this example, like I am taking a string column, right, and putting it in the array, right? Right, here. So let's actually, I can show you here, like, so if I do JSON array ag, okay, I need to connect to the other server. Right, this is a, so I say something like 1, right? Actually, this wouldn't be like this. So it's going to convert and produce an array like this, right? So now imagine there's something like, it's like create date from, I don't know, sys.objects, right? I think sys.objects has a create date, yeah. Yeah, so here now what it's going to do is take the entire create date is basically a timestamp value, right, in this catalog view. So it's going to take each one of those and convert it to a corresponding JSON type. Since it's a date time type, there is no date type or timestamp type in JSON. So everything will end up as strings. Similarly, if I were to put something like object ID here, it's going to be all numbers, right? Now, I can actually combine these two together, correct? So like if I want to say convert it, so I could say something like object, right? So what if I want to take the names and similarly date, right? Create date and put this way. So now what this is going to do is, first actually let me run this without the JSON array ag. So what happens if I run this? It's going to what? Create one object per row, right? If I paste it here, it's going to look like this, correct? So now what the aggregate is going to do is turn around, combine all of these JSON objects together, right? So by that I mean like it's going to take the second value, put it like this, right? And so on. No? That's what it is. Now the same thing, I mean, you could put it like here, right? Like you say, I mean, to take example. So I can say, I think string ag as a parameter, I think. Let's see. Yeah. I think it's one parameter. Yeah. So this is, I mean, how many of you are familiar with string ag? This is again an aggregate function which was added a few releases back. It takes basically some set of input and converts it to string, formatted string, and you can say what delimiter to put, right? It could be comma, it could be tilde, whatever, right? And it's going to produce a formatted string, right? So now JSON array ag does the same thing, except this whole thing is going to become a JSON object. So that's really what the difference is. Right? And same with if you want to produce an object instead, you can put an object tag here. So in that sense, it's really an aggregate. Well, all the type of output it's going to produce, right? String AG does not produce a JSON formatted string, right? It simply takes the individual values, puts them as some delimited string, right? Like either comma or whatever separator you want to choose. Whereas this one is going to produce a JSON document, whether it's an array or an object. And that's the only thing you would get. Oh, because say imagine I have a scenario where I have some IDs, like some values, right? I'm sending it to Event Hub or something, and it expects, say I have a table which is storing some metrics or something like that, right, of a device. And I want to produce an array which contains, say, measurements of the values, right? So now how will the JSON array look? I mean, I'll use object ID as a value here. A JSON array is going to look like this, right? No? Yeah, so now this is just a string. I could send it to Event Hub basis because it's a valid JSON array, and that's one of the use case, basically, right? Correct. It's expecting a JSON formatted array. And this could be more complex, right? The simplest example is just putting a bunch of numbers in an array format, JSON array format. But instead, each one of these could be a complex object. Like you could have a case expression here and say, okay, if some particular property is set, then I want to put an object instead or some other value. You can do all of that, right? Again, it's just a use case of transforming into strings some set of rows, right? But it's a valid JSON array or an object. That's really what it is. Array meaning what? What do you mean by array? SQL doesn't have array type, right? So the only way you would send some values like this to some application is either as like some comma separated string or XML, or I mean, if it wants to, you want to send it as one value, right? Otherwise, you can send a relational set. That's also fine, right? This is just a primitive, like where you may have scenarios where you want to construct JSON arrays or objects in the T-SQL, and this provides you the capabilities. Yeah, I think that's about what I had here. Let's see. Yeah, I think that was it. Any other questions on this? Yeah. Yes, much. Yeah. 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 Yeah, very much, very much. Well, yeah, XML is actually, okay, so high level, both are XML, JSON, or some data interchange formats, right? XML, you should think of it as a superset format because it's much, like type system is much richer in XML. It has schema and all of that, right? Whereas JSON as a format was designed primarily for data portability, right? And at the same time, one of the big objectives with the JSON standards, the way it originated was, in order to build XML parsers, for example, it's very complicated, right? Because it needs to deal with all these complex type system structures and so on. So the JSON came about because people didn't want to write those complex things, and they wanted a simpler format. So that's why this whole JSON format or JSON standard is primarily meant to be lightweight. That's why you would find this being used in a lot of REST, pretty much any REST API today. If you go, it will return output as JSON. It will take input as JSON, right? Similarly, if you are dealing with, I think David and folks showed you earlier, if you were there for the session, like Azure Functions, I mean, you call some Azure function, I mean, you can get the output as JSON, right? You call some REST API or ARM REST API and Azure portal, I mean, it's going to return the information as JSON. So you just become like one of the de facto data in exchange format, right? Because T-SQL or TDS is meant for really only like specific clients, right? Like you need a driver to parse this. Whereas this one, you can just use like a simple REST API to get the value as a string, right? Which would be in this JSON format, and then do something with it, right? And that's why we want to extend the SQL capabilities. So there are a lot of applications which have data in relational format, right? And you are integrating new applications and you want to send it as JSON, right? Or similarly, you build new applications which are primarily dealing with JSON. So yeah, so we do see pretty much all of the new APIs are all pretty much using, yeah, that's the way you communicate with services. And yeah, your phone mobile apps, most of them are exchanging JSON calls, right? So it's just a much more compact format. Like I said, the type system is very primitive. It only has number and strings, that's it, right? So it's very easy to construct such a string and send it to anybody. And similarly, the receiving API or endpoint can easily parse that, right? So that's why it doesn't have many complex structures. And that's why it's, I think, very popular. Any other questions on that? Yeah. Yes. No. So okay. So good question. So let's go back to this example here. So question was, why is the type, even though it's optimized, right? Like where is it? Yeah, here. So currently the JSON value function returns everything as string, right? So that change has not been, but there is a syntax in the standard which we will implement soon, right? Which would, and there are other principles. So today in the SQL language, a function can return only a specific type, right? And we cannot go and just change JSON value today to return an int, right? Depending on the use case or the column, right? So what we will have is you can do something like this in the future. It would be, you would do this. I mean, it's still like a cast, but you would do, you would use this instead. And the other thing is, we will know if this was a float or a string, and won't do the conversion. So that's how most of the databases deal with it. Even though it's all in binary format, these function transformations work like this. And there might be other optional syntax which we could add, and you just use a dot notation, right? So you would say something like price, right? This is something we want to do, and this would return a float column or integer column, right? This would be shorthand of doing the JSON value, right? So these are capabilities we want to add at some point, but currently, yes, it's all. Why is my cursor going like this? Currently, it's all dealt as, it returns as strings, and that's why you need to do the float. Okay, that's pretty much. Thank you everyone for staying for the last session of the day. Hope you guys had a good time, and tomorrow we have a workshop where we are going to show a lot of this integration, the data API builder and REST API integration. So if you can, please drop by for that. Cool. Thank you.